section number 35 is entitled Solving Equations by Factoring. And I meant to say, if I said it incorrectly, section number 29, Solving Equations by Factoring. If you have one expression times another expression and you get 0, 0 is a special type of number. If any one of these quantities are 0, if the box equals 0 or the triangle equals 0, then the product on top equals 0. If a product of 2 things or 3 things or 4 things or 50 things equals 0, then one of those things is 0. No other number has that property. If I tell you that what's in this bracket times what's in that bracket is equal to 10, you can't, suppose you had x plus 2 times x plus 4. You can't say, well, this is simple. I'll let x be 8, and I'm done. So that will be 10. Fair enough, that would be 10 if x were 8. But this would be 12. And 10 times 12 is not 10, it's 120. But when it comes to the product equaling 0, when it comes to a product equaling 0, a product is made up, the things that make up the product are called factors. This times that. What I just called this and that, those are the factors. If I let x equal 2, for example, that would be 0. 2 minus 2 is 0. And this factor, 0 minus 5, is negative 5. And you know what? When you multiply those two numbers, you really do get 0. And if instead I said x is 5, if I said x is 5, if I said x is now 5, well, 5 minus 2 would be 3, and 5 minus 5 would be 0. And here. 3 times 0 is 0. The x can be 2 or x can be 5. It's not because your teacher said, for some mysterious reason, if you have this, you say, oh, either x minus 2 equals 0 or x minus 5 equals 0, and you solve both of these equations. You get first x equals 2 and then x equals 5, and you'll get full credit, but you have no idea why. Okay, a product equaling 0 is special. One of the things that you are multiplying must be 0. 7 times 4 times negative 2 times the number pi times 2 to the 17th. This is not 0. Because none of the quantities that I multiplied, none of these were 0. I may not know what it is, but it's not 0. I can always tell you pretty quickly if a product is 0 or not. One of the things being multiplied must be 0. Okay, I've talked enough, so let me do some problems. While I erase my board, remember, if the product is 10, one of the factors can be 10, but the other ones better be 1, because only 10 times 1 is 10. So there's not much to do in this section, to be honest. Suppose you have x minus 4 times x plus 3, and I tell you this product is 0. Well, I just underline the things that are being multiplied. It's the first bracket times the second bracket equals 0. So either x minus 4 equals 0, first factor is 0, or the second factor, x plus 3 equals 0. Now, when you subtract two quantities and you get 0, just write down the two things that you subtracted and put some horizontal lines in between them. They're equal. That's why when you subtract them, their difference is 0. They're equal in one another. Bring this 3 over to the other side, it becomes negative 3. those are your two answers. X is 4 or X is negative 3. We can check this. Let's do the check for X equals 4. And then on the right side, we'll do the check for X is equal to negative 3. So I recopied the first equation with a couple of variations. Instead of X, I'm going to write 4. And instead of equal sign, I'm going to put an equal sign with a question mark on top. Because I don't know what to equal. If I knew they were equal, I wouldn't check. If I knew 4 worked, I wouldn't check. Bracket X minus 4, bracket, another bracket, X plus 3. Does this equal 0? And of course it does. 0 times 7. Does it equal 0? Yeah. 0 times 7 is 0. 0 equals 0. We have it. Let's try negative 3. Bracket X minus 4. Close the bracket. Open the bracket. X plus 3. Close the bracket. Does that equal 0? Well, negative 7 times 0. Does that equal 0? Of course it does. As long as one or both of those numbers are 0, the product will be 0. We are multiplying. 0 does equal 0. So we know they're correct. We're multiplying the stuff in the brackets. One of the things I do in class when I teach an algebra class is I'll ask my students, you see what's left on the board? What does that equal when X is, say, 10? Or, when X is 10. What does that equal when X is 10? And to be honest, the answers I get are very poor. They'll tell me 6 and 13. They'll tell me the answer is 6 and 13. No, it's not. There's no and there. It's times. It's not 6 and 13. 10 minus 4 may be 6, and 10 plus 3 may be 13. But we're multiplying. What you should be telling me is 78, or 6 times 13. What I'm really looking for is that times. Of course, if you tell me 78, I'll know that you times them. But don't say and. That means if you say and, if you really think it's X minus 4 and X plus 3, and you set it equal to 0, you have absolutely no idea why we say each of these factors equal to 0. You have no idea at all. So you might get these problems right every time, but it's no fun. If you have no idea what you're doing, or you know exactly what you're doing, you just don't know why, then it's going to be hard. You're not going to enjoy the course. If you have, say, this problem which we've been beating to death, you have this. Well, you should set it equal to 0. It's a quadratic equation. Bring the negative 6 over to the other side. These are terms. They're separated by addition and subtraction symbols and equal signs. Although I might write the minus in front of the 6, or the negative sign, it's really not a subtraction. It's a negative sign. It should be written a little bit higher. Negative 6. That's why I didn't use it as a separator, like I did that addition symbol. When you move a term across the equal sign, like the negative 6, it moves over as plus 6. Not even positive 6, but plus 6. It becomes plus 6. And now the right side is 0. And we try to factor this. But we've done this one before. Since it's x squared, I factor it this way, and I want two numbers that multiply out to 6, but add up to the number in front of x, which is 5. Positive 2 and positive 3, they really multiply out to 6 and add up to 5. So I set it equal to 0. So now I have a product equaling 0. A product of two factors. So either the first factor is 0 or the second factor is 0. If you bring the positive 2 over to the other side, it becomes negative 2. It had nothing. It's like blank. When you bring the positive 3 over, it becomes negative 3. And if you wanted to check it, you have to show that x squared plus 5x equals, in this case, negative 6. If I try negative 3, when I square it, I get 9. And when I add on 5 times negative 3, that gives me 9 plus negative 15. Well, it's not 9 plus 15, so then it's 9 minus 15. You read it backwards, you get 6. You get positive 6. 15 minus 9 is positive 6. But if you read it backwards, you were wrong. It's not positive 6, it's negative 6. And that's exactly what it is supposed to equal, negative 6. The left side, when x is negative 3, equals negative 6. And when x is negative 3, the right side is negative 6. So it's checked. And you can check it for negative 2 as well. So we just learned that when you factor this, you get x plus 3 times, say, x plus 2. This is called an identity. It's not conditional. The right side and the left side are always equal. If somebody told you that 2x plus 3 is equal to 5, well, that's not always true. If x is 10, that would be 20. 20 plus 3 does not equal 5. But under the condition that x is 1, 2 times 1 is 2, plus 3, 2 plus 3, you better believe it, it's 5. This equal sign is not always valid. It's only valid under the condition x equals 5. This here is called a conditional equation. But, for example, 3x plus 2x is always 5x. Always. That's called an identity. This is always that. That is always this. It's not a conditional equal sign. That is, you can't say solve for x. If you did, you would conclude that x can be any number you like. Alright, so enough with this. If somebody asks you, like myself, what does this equal? What does this equal when x is 97? I claim, based on what you know, that is, based on what you see on the board, this is not a hard problem. I know a lot of you would say, oh, let me go run and get my calculator and compute 97 squared plus 5 times 97 plus 6. The reason I wouldn't recommend using a calculator is because, it's time consuming. You have to go and find it, you may have to get batteries, you have to push a lot of buttons. I mean, who wants to waste time in doing their math homework? I would just say 97 plus 3 is 100, 97 plus 2 is 99, and 99 times 100 is 9900. Okay, which is a lot faster than computing this on a calculator. I can do 10 of the problems on the right side, well, maybe not 10, 3 or 4 before I can do one using a calculator. Okay, so what point am I making? The point I'm making is equal. If you have equal, the two sides are going to be the same. That is, plugging 97 in for x here, you're going to get the same answer if you plug 97 on the right side. But it happens to be friendlier to use the right side. 97 plus 3 is not a hard problem. 97 plus 2 is not a hard problem. The product is not hard. calculating 97 squared, that's hard. 450 and 35, 485. That wasn't so bad. Plus 6, so that's 491. You want 9,000? This is going to be 9,409. That's what I claim 97 times 97 is. But that's much too hard to do. 67, 63, 87. See how bad I am with math. Wow, I didn't make an error, 9409. Okay, it's a lot easier to do it on the right-hand method. Now, if somebody asks you what this equals when x is 0, I might go with the left-hand side. When x is 0, the answer is just going to be 6. Because 0 squared is 0, 5 times 0 is 0. You add those two zeros, you get 0. 0 plus 6 is 6. But in the left side, 0 plus 3 is 3, 0 plus 2 is 2, 3 times 2 is 6. I can just read it off. Whenever you have ax squared plus bx plus c, when x is 0, that's what you always get. Think about why. So sometimes I would use the left side, but you need to be mathematically mature enough to know you can use either side. They're the same. That's what those two horizontal lines mean when it's an identity. Okay, it puzzles me that students can do this problem. 97x plus 3x. On an exam, most of the students will say 100x. Question is, simplify this. The answer is, of course, 100x. And then I say, what's 97 times 5 plus, say, 3 times 5? And I'm like, this was part A, problem number 7, part A, and this was problem number 7, part B. Evaluate this using part A. The answer is, well, I'm just telling you what x is. So you get 100 times x, where x is 5, and that's 500. Okay, after all, put units in. Put units in. You have 97 $5 bills, and somebody gives you 3 more $5 bills. You have 100 $5 bills, which is $500. And now that you use the units and you got the right answer, erase the units so your teacher doesn't say, why are you changing the problem? And there it is. Okay, let's get back to solving equations by factoring. You had x times x minus 4 is equal to 12. We've done these problems already, and I showed you a nice shortcut. If this is some number, this number is 4 less, and their product is 12. Well, let's try to get positive numbers. This is the smaller one. Say x has to be more than 4. Let's try 5. If x is 5, if that's 5, then that number will be 4 less, which is 1 large. That multiplied out to 5, not 12. If x is 6, the other number is 4 less. That's 2. And what do you know? Their product is 12. So one answer to this problem is x is 6. Another answer is if you have -2, 4 less, -2 minus 4 more is not -2, excuse me, but it's -6. And if you multiply those two numbers, so here's the number, x, and here's 4 less, that's x minus 4, we also get 12. Remember, a negative times a negative is a positive. So here are your two answers. X is 6, x is -2. And it may have taken me a bit to talk about it, but it wasn't that hard. I mean, I tried 5 and 4 or less. I got 5, which is below 12. I tried 6 times 4 or less, which is 2. And my product was 12. So there was one answer. Another answer is just put negatives and make both of those numbers negative. But the larger number needs to be x, because x is bigger than x minus 4. You have a number, you take away 4, you get -6. And the product is still 12. These are the two answers. It doesn't take more than 5 seconds to do this problem. But unfortunately, as I said many times already, this is an algebra class, and your teacher may want you to use algebra. So you have x times x minus 4 equaling 12. Distribute. You get x squared minus 4x is equal to 12. And understood positive 12. When you bring it to the other side, it just becomes minus 12. And then you try to factor. Since it's x squared, it's a trinomial where the leading coefficient is 1. I put x and x, I want two numbers that multiply out to -12, they add up to -4. And I think those two numbers are -6 and +2 equals 0. So either this factor is 0, which is when x is 6, or that factor is 0 when x is -2, because their product is 0. And those are the answers I had 5 minutes ago. And to get the -6 and the +2, it was very similar to what I did initially. I want two numbers that multiply out to -12 that add up to -4. They multiply to -12, but they add to -4. What I wanted was the product is +12. That is, they multiply out to 12 and they differ by 4. Instead of adding up to -4, I wanted them to differ by 4. It was very similar. And I didn't have to distribute. I didn't have to bring numbers over. I just got right to pretty much to this step. Although the rate of difficulty from this step on was the same as what I did earlier. But, like I'm saying, I didn't have to do the first two steps. And hopefully your teacher would at least show you the way I'm doing it. I can understand your teacher not wanting you to do it on an exam because it's an algebra course, but in my opinion, that was not an algebra problem. Not in the least. I would never in real life solve that by algebra. Okay, one more problem. Last one. Suppose you had x minus 1 divided by x plus 4 is equal to 3 over x. So we want to find the LCD, so we can multiply and clear out the denominators. The first factor in the denominator I see is x plus 4. And clearly I didn't write it down in the corner here. How do I know that? I didn't write anything down in the corner yet. So I have to write down x plus 4. And when I look in the corner, I realize I did not write down x. So I write down x. Put the x in the front. That's my LCD. I'm going to at least denote that I'm multiplying both sides by x times x plus 4. Denote I'm multiplying the right side by x times x plus 4. Coincidentally, the x plus 4 cancels out to 1 so long as x is not -4. So if I I get negative 4 in the end, I reject that answer. And here, x over x is 1, provided that x is not 0. 0 over 0 is not 1. Alright, so now I distribute. I multiply the x by x minus 1, which is x squared minus x. X squared minus x. And then I multiply the 3 by x plus 4, which gives me 3x plus 12. 3x plus 12. This is a quadratic equation. And since I haven't understood 1x squared on the left, I'm not going to bring the x squared to the right side, because it would then become negative x squared. I'm going to bring everything else over. Let me be very clear on what I said. It's not enough for this to just be 1x squared. There can't be any x squared on the right side either. So I'm going to take away, or denote, I'm taking away 3x, and I'm taking away 12 from both sides. On the right-hand side, it vanishes to 0. On the left side, I still have x squared. I still have to take away 3x, and I have to take away 1 and take away 12. That means I have to take away 13. And one slight mistake. You only caught that, of course, on the top. X times negative 1 is negative x. Excuse me. Okay. So the x squared. So the x squared stays x squared. If you take away x and you take away 3x, you took away 4x, and don't forget to take away the 12. Now I want to factor this. We'll do that in the right-hand corner. Since this x squared is x followed by a number times x followed by a number, the two numbers should multiply out to negative 12 and add up to negative 4. Numbers that multiply out to negative 12. Now, they're going to add up to, that means the signs have to be different. Because to get a negative, the signs have to be different. And when we're adding numbers with different signs, if we want to get a negative sum, we should let the larger number be negative. So we have 1 and negative 12. That adds up to negative 11. 2 and negative 6. What do you know? That adds up to negative 4. And that's my numbers. Positive 2 and negative 6. And this product is 0. This times that equals 0. So either this is 0, which happens when x is negative 2, or that's 0 when x is 6. And none of my two possible answers are my numbers that I won't allow. Okay, this is my final answer. If it turned out that this 6 right there, if that 6 was negative 4, I would reject that, because I can't allow negative 4. I can't allow negative 4. But that didn't happen, so we shouldn't be rejecting anything. Okay, this finishes up the section on factoring or solving equations by factoring. And good luck with it.